Hey everyone, welcome back to Tenses Titan. Here we are again with another exciting machine learning project. So today we are going to build a heart disease prediction system. So here we are going to train a machine learning model using a real medical data, and we will also deploy it so that anyone can use it. So let's dive into it. So before we start the coding part, let's see what's going to be the workflow for our project. So first we are going to load our heart disease dataset. This is a real medical data with 303 patients. After loading our dataset, we are going to visualize our dataset so that we can understand our dataset much better. And after the data visualization and the analysis of our dataset, we are going to do some data pre-processing where we will be converting all the textual data into numerical data so that our model can be trained on it. And after the data pre-processing, we are going to split the dataset into the training and the testing set. And after splitting our dataset, we are going to train our model on the training set. And after the training of here, we are going to use logistic regression as this is a classification problem. So we are going to use the logistic regression model. And after the training of our model, we are also going to evaluate our model so that we can see how good our model is performing on the test data. And after the evaluation of our model, we are going to deploy our model with the help of the Streamlit so that anyone can use it online. So this is the workflow for our project. Now let's jump into the coding part. So let me just quickly create a virtual environment for our project and install all the required dependencies which we are going to use in our dataset. So as you can see that our environment is ready. Now let's create a file. Let's name it heart disease prediction.ipyn. We are using Python notebook so that we can be able to visualize much better. So now let's first import our essential libraries. So we need NumPy and pandas for data manipulation, matplotlib and seaborn for beautiful visualization, and we are going to use the joblib to save our model. From scikit-learn, we are importing train test split, and then our machine learning model, which is the logistic regression and the evaluation matrices. We are importing warning because we are suppressing warnings to keep our output clean. So let's run this. Now let's load our heart disease dataset. So this is a real medical data with 303 patients. The target column tells us 0 means healthy, 1 means disease. Now let's see what we are working with. So as you can see that we have the 303 rows and 14 columns, which is basically 13 features plus our target variable. Now let's check our data types and see if we have any missing values. So this shows us all columns, the types and memory usage. Now let's check how balanced our dataset is. This is a crucial because if we have way more healthier patients and diseased one, our model might get biased. So here we have 165 disease cases and 138 healthy cases. That is pretty balanced. A 1.21 ratio is perfect for training. Now we are going to analyze our data set. So we are going to visualize our data. So I'm creating a 2x2 subplot to compare the age, cholesterol, max heart rates and our target distribution. So you can see how I am separating healthy, which is green, from the diseased patients in each histogram. So as you can see how diseased patient tends to be slightly older and their max heart rate is often lower. These patterns will help our model to learn. Now let's see the correlation. These correlation heat maps are basically very important because they show which features are related to each other and to our target. You can see that the dark red means strong positive correlation and the dark blue means negative. So here the CP, the thalage and the slope have strong correlation. These will be powerful predictors. Now it's time to prepare our dataset for training. So we will separate X, which is our features, from the Y, which is going to be our target variable. So X gets all the columns except the target column and Y gets only the target column. Now let's train on all your data. Never train on all of your data. So we are going to split it into 80-20 ratio where 80% is the training and 20% is for testing. The stratify parameter ensures both sets have the same healthy disease ratio. This gives us honest accuracy results. Now we are going to do the feature scaling, like age ranges from 20 to 100, but cholesterol goes up to 600. So without scaling, our model would think cholesterol is more important just because the numbers are bigger. So standard scaler fixes this by making all features have mean is equal to 0 and STD is equal to 1, which is standard deviation. So fit transform on training, but only transform on test. We never fit on test data. That would be cheating. So now we will train it on the full training set. So max iteration going to be the 100, which ensures the algorithm has enough iterations to converge. Now let's test our model using the cross validation. So CV splits our training data into 5 folds and test each model 5 times. This gives a reliability accuracy estimates. So logistic regressions usually perform best here. It's simple, fast and interpretable for medical data. So training is instant because our dataset is small and logistic regression is also efficient. And now it's the time for the evaluation. So we predict on both training and the test sets. Training accuracy shows if our model learned and the test accuracy shows if it generalizes to new patient or not. The classification report gives us precision, recall and the F1 score for both classes. So around 85% of test accuracy is excellent for medical predictions. So if training accuracy is much higher than test, we would have overfitting. But here they are close. Now let's see the confusion matrix. Because confusion matrix is crucial in medical MLs. It shows the true positive, true negative, false positive and false negatives. So in healthcare, False negatives are dangerous because there is a missing a disease. So while false positive, false alarm causes unnecessary worry. So diagonal values, correct predictions should be high. Off diagonal values, which are the mistakes, should be low. So now let's save our trained model and features name using the joblib. So this will create a pickle file which we can load later without retraining. And I'm storing both the models and features names so our web app knows the correct feature order. So now we have saved our model. Now it's time to build a web app for our. So now as our model is saved, now let's build a web app for our project. So we are going to use Streamlit for building a web app for our project. So let me just quickly create a file. Let's name it heartapp.py. So we will first import the necessary dependencies. And now I'm setting the page configurations. Let's make some custom CSS styles so that our prediction buttons in red and creates a beautiful prediction boxes. Streamlit basically makes the deployment incredibly easy because you don't need the knowledge of the HTML, CSS or JavaScript. So it is very easier for you to make a web app for your projects. Now as we are keeping the st.cache resources decorator, which is basically that it loads our model once and caches it. So it doesn't reload on every user iterations. The try except handles the missing files gracefully. Now let's build the interface. So I'm using 2 columns for a clean layout. Column 1 has the personal information and hard metrics. Column 2 has the rest of the data. So Streamlit's widget are amazing. Sliders for numerical values, select boxes for categories. The format function makes options human readable. So when the user clicks predict button, we collect all inputs into a dictionary, convert them into the data frame and scale it, and then we will predict. So we get both the predictions and the probabilities. And then we display 3 matrices in columns, creating a beautiful plotly bar chart and shows the personalized advices as well. We are here using the plotly because it creates an interactive chart which user can hover for exact values. And finally, the sidebar shows model info and key risk factors. The disclaimer of the bottom is crucial. This is educational, not medical advice. Always include such warnings in health-related ML projects. Let's check whether our project is working or not. So we are going to write streamlit run heartapp.py. So here is our web app. Now let's add some values and test it whether it's working or not. So as you can see that our project is working very fine. Now it's time to deploy our model so that anyone can use it online. So we are going to deploy our model with the help of the Streamlit Cloud and the GitHub. So let me just quickly put all our code on the GitHub. So as you can see that our code is on GitHub now. Now we will quickly go to the Streamlit Cloud and we will click on the create app. Now let's select the repository, the file name, and in the advanced setting, we are going to set the Python version and then click on the deploy. So as you can see that our project is now deployed. Now let's test that whether it's working or not. So here it is, it's working very fine. And that's it. We build a complete end-to-end machine learning project from loading data to training a model to deploying a beautiful web app, which anyone can use it. So you can also put this link in your resumes so that anyone can access it and see what you have built. So if you found this helpful, drop a like and subscribe for more ML tutorials. And if you got any questions, you can comment below. Thanks for watching. This is Tensor Cited signing off.